connects the Key West location to the rest of the network has recently been added and has not yet been configured for OSPF. In addition, at least one configuration error exists that is preventing OSPF from functioning correctly in other parts of the network. So we'll be doing some troubleshooting on that. We'll configure the new Key West router for OSPF and identify and correct any remaining configuration errors in the simulated network. All the passwords have been set to Cisco, CISCO. We have a lab topology, which is there's a host A, host B, host C, host D, and host E, and they are connected each to a router. So that would be router 1, 2, 3, 4, 5 routers. They'll be named Tampa, Orlando, Daytona, Miami, Key West. So we'll run through some commands here for this exercise. One of the commands will be configure terminal, which enters global configuration mode from privileged to exec mode. Enable, which enters privileged exec mode. End, which ends and exits the configuration mode. Network, which activates OSPF on a specified network and places the matching interface in the specified area. Ping for IP addresses basically just sends an ICMP echo request to the specified address. ICMP is Internet Control Message Protocol. We will use the command router, OSPF, and then the process ID. This enters the configuration mode for the OSPF process. We'll show IP OSPF neighbor interface, which displays the OSPF neighbor information. That will be really handy for troubleshooting. We'll be able to actually see what's going on with the other routers in the network. Show IP protocols, that displays the information about the active routing protocols. Show IP route displays the routing table. And show running config, which will display the active configuration file. All right, so let's examine the routing topology. So we'll log into the Key West router and we'll run a command to display the routing table in Key West. So let's do that. That would be Key West. Just go with this here. All right, so as we said, password is the school, no problem. And we'll do enable, password again, and then show IP route. Okay. And again, show IP route displays the IP routing table that's currently on the router. So this is interesting. A couple things to notice here on the IP routing table. There are 7 routes on this table that are preceded by an O. So it would be these 3 and then these 4, I believe. So that if you look up here to the codes, O is OSPF, which is what we're doing troubleshooting on right now. It's open shortest path first. And then another interesting thing, the first 3 that are OSPF also are preceded by an IA, which indicates that there are 7 OSPF routes in this routing table, and that 3 of the routes are learned from a different OSPF area. That's interesting. Okay, so so these are learned from one area, and These are learned from a different area. Okay. All right, so let's examine the configuration. What command would I issue to display the currently executing protocol configuration on Key West? That would be show, let's see here, that would be show IP protocols. Okay, and again, show IP protocols is, it displays the information about the active routing protocols. So anything that's actively, any active protocol that's currently running will be displayed here. And notice here, we got a, it should show the routing protocol here. So right here, okay. So it's showing routing protocol OSPF1, outgoing update filter list for all interfaces not set. And then it's also showing a router ID of 3.3.3.3. So the number of areas in this router are 2 normal, 0 stub, 0 NSSA, maximum path 4. Okay. Let's see here. So is the OSPF routing protocol running on Key West? I would say the answer is yes, because we're seeing it here by punching in show IP protocols. Okay, so now we should look at the running configuration on Key West. We could do that by issuing the show running config command. This shows that the router1 OSPF1 command has been issued to create the OSPF process. So we can do show running config, and it's going to be built. It's going to build a configuration and give us the version, timestamps, and interface router. Okay, so this is a good question. Why is the router ID 333? So what is the router ID? It's 3.3.3.3. We know that. Why is it the router ID? The router ID is 3.3.3.3 because the router ID command was issued in the router config before any OSPF network commands were entered. The router ID had not been manually configured. The router ID for Key West, if the router ID was not manually configured, the router ID would most likely be 200.120.45.254, which is the highest IP address assigned to an up-up interface on the router. Okay, let's see if we can find that. That would be back. 200, 120, 45, 254, right here. Okay. All right, so if OSPF was not manually assigned, if the OSPF router ID was not manually assigned, it would have been 200.120.45.254 because this is the highest IP address assigned to an up-up interface on the router. So OSPF will automatically assign itself to the highest IP address on the router if it's not manually assigned. Okay. OSPF will not use the same ID for multiple processes. Let's consider a situation where two OSPF processes are configured. Router OSPF1 and available loopback IP interface address has a router ID. When the OSPF process 1 is configured second, it would take the highest available loopback interface IP address, which is actually the second highest overall. The highest went to process 100. If you save the configuration and rebuild it, different router IDs will be assigned when you first deploy it. Cisco IOS lists OSPF processes in numerical order in the running config. OSPF process 1 will appear before OSPF process 100, which results in process 1 selecting a router ID first. Thus, when you reload the configuration, OSPF process 1 will use the highest IP address configured on the loopback interfaces, and OSPF process 100 will use the second highest. Okay. Lastly, let's consider a situation where the manual router ID has not been configured and no loopback interfaces exist. OSPF will then use the highest IP address of any physical interface that are in the up-up state. If no physical interfaces are above, OSPF will warn you that it was not able to select a router ID and ask you to configure one manually or bring up an interface that is already configured with an IP address. After the device reloads, you may have difficulty predicting which interface will come up or the order in which interfaces will come up. The total time that elapses between the first interface that transitions into the up state and the last interface that transitions into the up state may take only a few hundred milliseconds, but OSPF will still use the first one that makes the transition. The router ID selection process that OSPF uses is complicated because it guarantees that a router ID will exist if OSPF is running. Configuring a router ID manually is the best practice to not only avoid confusion, but to set a stable, unique, and predictable router ID. So the preferred method by Cisco is the best practice by Cisco is to configure a router ID manually. That's best practice, and that's their suggestion to avoid any confusion. So this will go back to here, which is which is actually this router OSPF 1. Okay. All right. So let's find out something else here. Let's do this. Let's do show running Okay, so we're going to show running config, which is the running configuration of the router. Uh, Interesting to just a note, it should be show running dash config, not running space config. So what we see here is, what do we see? We see, let's look at that first interface. We see the first interface has a description, an IP address, and what we're going to see is it looks like there's from a troubleshooting perspective, it looks like there's a misconfiguration here. It shows that the network commands are misconfigured. The wildcard masks do not match the subnets configured on the interfaces. So I got my subnets here, my subnet here, and I got a wildcard there and there. So is it 200, 193? So so we can let's see here. All right. So we could issue some commands here to correct some of those issues. So let's do configure terminal. Oops. Okay. So now I'm in the configuration mode. Let's get into that router. Let's do router OSPF1. So this is the first OSPF configuration for this router. And let's see here. No. All right, so basically we'll just change the problems here. We'll just change. We'll start with area 0. We'll get that out of there. Then we'll start with area 3. We'll get that out of there. And then we'll start again with area 0 and start again with area 3. And I think what we want to do here is we want to put we want to configure area 0 and area 3 so they have the correct wildcard masks. So, okay. That would be no network. 200.120.45.224 0.0.0.31 area 0. So we'll get that out of there for now, and then we're going to do the same thing here, but I'm going to do 200.45.1.2.0.0.31.3. All right, so we'll just get that out of there. So let's do those two again. So the area 0 will work on first. We'll do that again. So it'd be network 200 20 to 45.252, and then this would actually be okay. So that's that would be the correct wildcard mask for that one. Which wildcard mask is just the reverse of the subnet information. And then we'll do the same exact thing for area 3. It would be 192. 0.0.0.15 area 3. Perfect. Now we can kind of look at the rest of the topology here from Key West. We can look at all the different interfaces. So let's see here. So I wonder if I could ping. Can I ping? Let's see if I could ping. I don't know if I could ping from the router or not. Wait, I should. Let's try. I don't know if this will work. Let's try. Oh, okay. So yeah, I'm just pinging other routers now. Okay, so basically that one just said, yes, I'm able to get out. So let's try 120. Okay. So yeah. So I'm getting out. What did I do? Oh, I don't know. Wait. Oh, that actually worked. All right. Let me see. Oh, that didn't. Okay. So yeah. So there's another router here that is actually missing from the routing table. Okay, that's good that I did that because I didn't realize it first. So yeah, it's missing. Okay. So um, let's go back. We can take a look at the IP route again. So show IP route. Huh. So this is kind of interesting. So I'm able to ping. Uh, I'm able to get out to which one failed here? Yeah. So here, what did I do? All right. So 121.7. So I was able to ping to get out to 200, 120, 45, 120, 237. So yeah, I'm able to get out, but the other router does not know how to route back to the address. So let's go. This is another one I can do real quick. Ping 200 120.45.1. Nothing. Nothing. And then I can do the other one too, just to see 105.60. Okay, let's try that. Okay, so yeah, those pings fail. So let's do back to show. Oh, actually, let's go to the other router. Password. Whoops. So and oops. No, this is good. And then good is there. So we can do show IP protocols. Alrighty, so OSPF1 router ID is 2.2.2.2, and the routing is 120 200.120.45.0 0.0.0.255 area 2. So we can do show IP OSPF neighbor to determine where this router has successfully established adjacencies with its OSPF neighbors. But on this router, by running that command, it's actually just blank. So there is no adjacency here. There is no neighbor. So we need to correct that. So what we'll do is we'll go back to, we'll stay on this router, conf t, and let's do router OSPF1. So basically we're gonna set up brand new OSPF for this router here because we just did a show IP OSPF neighbor and it was blank, which means there's nothing has been put in yet. So we'll work on that right now. Should be router OSPF1. So this we don't like. So what we'll do is we'll get rid of that. So this goes back to what we just did on the other router. We're going to do no network 200.120.45.0 0.0.0.255 area 2. So basically just wiping that out of this router. So we'll do no network 200.120.45.0.0.0.255 area 2. Gone. So now we'll set up the proper adjacencies for area 2 and area 1. So let's do that. So that would be just network 200.120.45.0 0.0.0.53 area 2. Okay, I'm gonna do 45.236.0.0.3 area 0. And we'll do one more, which is going to be 240 area. Okay, so now that we've completed these commands, the network has now converged. You should see an OSPF neighbor relationship from the routers at this point. So let me try that other command again, see if I can get that to work. Oh, still working? No. Okay, so let's go back to this. No, one more. I thought I had that already. No. Okay. It sees it. Okay, and then we'll do show IP route. So it'll be show, it's here. Show IP route. Okay, so we could see there should be 4 now, yes, and they're all here. Well, we got 4 of them now. So the router successfully established adjacencies between the 2 routers, yes. So let's go back and we'll try that again. That ping is good there. Yep.